Human habitation is about more than simply surviving. True human habitation is about thriving, regardless of what planet you are on. We will create a living environment for people on Mars that is Earth independent but lifestyle rich. A place where astronauts can live, work, rest and play, and ultimately take the most important step towards humankind becoming a truly multiplanetary species. Each module within the Mars habitat is bespoke to its purpose, yet flexible to allow for a variety of settings. The lab serves all the astronauts' working needs. It's a place for experimentation, testing and reporting. A circular mobile rack system allows for multiple activities to run concurrently while maximising space efficiency. This commitment to efficiency continues into the living space, this time with the racks containing all the amenities critical for everyday life on Mars. But, more importantly, the living area is very much a human space, with home comforts, natural surfaces and soft furnishings. The sleeping pods offer a sense of privacy within an intense environment. Each astronaut has their own spatially efficient berth for rest and recovery. The critical link between all of this are the hexagon connectors, containing the environmental control and life support systems. The hexagon connectors are the life source of the habitat and allow additional modules to be added over time. The habitat connects to the Martian environment with a sample hatch, suit ports, and the Martian rover. Additionally, one of the hexagon connectors can also serve as a large airlock. We have also included penetrations for services and for views out to the Martian landscape. The reality of life on Mars includes extreme temperatures, solar and cosmic radiation, and meteorite impacts. We intend to mitigate as much risk from these elements from day one for the astronauts. This includes 3D printing the protective shell using Martian regolith before a single person sets foot on the red planet. Months before the astronauts' arrival, a fleet of autonomous construction robots will have built the external structure. There are 4 different types of robot, each with a specific function. The spherical Scout bot propels itself across the Martian plains. Using ultrasonic testing, it identifies appropriate Martian regolith for use in the construction and notifies the other bots as to its location. Once regolith has been identified, the digbots are deployed to retrieve, crush and deposit it near the site of the habitat, a method of stockpiling materials close to the construction site that has proven effective over decades of terrestrial construction. At the site, a scaffold of inflated structural tubes forms the support structure for the shell to be 3D printed over. The distribution bots then take the regolith that has been deposited on site to apply a thin yet wide horizontal layer around the support structure. Following closely behind are the fuse bots, which use microwave technology to solidify the loose regolith into a solid layer. This process is repeated over and again until a full shell structure is formed. The engineering of the shell is based on a compression-only structure, as 3D printed regolith will not withstand high tensional forces. Only when this protection shield has been built, scanned and verified by scientists on Earth can the manned mission to Mars arrive. The astronauts bring the lightweight prefabricated pods that form the structure's interior. Starting with the hexagon connector, these expandable modular pods are quick to construct and safe to occupy. The result is a Mars habitat where astronauts are active inhabitants, equipped with the living, working and rest spaces they need to perform at their best. With our Mars habitat, HASSELL and EOC have designed a place where humankind can be truly Earth independent, a place where science can find life and life can find science.